Welcome back to Garage Time. Finally, we're going to spend some time on this 356 Porsche.
Garage Time.
I want to start putting this car back together, and today's focus is going to be on the front suspension. But it needs to be refurbished. Now, a lot of professionals and Porsche owners will tell you this is not a DIY project. This is for highly trained, factory sort of trained professionals. But I'm going to take it as far as I can. And as I've mentioned before, I've owned this car a long time, and I've been lucky enough to acquire a bunch of parts and some tools along the way. So I actually have 2 of the 3 major tools for checking and setting up the front suspension. So I'm going to give it a go. Got nothing to lose. I promise not to damage any of the parts. Clearly, this stuff has been sitting a while and needs to be completely gone through. I do have some of the new parts, but this is mostly just an investigation on what is going to take to get this rebuilt and what parts I might need to buy. Okay, this is where that suspension attaches, and it was removed at least 5 years ago when this car was taken apart for rust repair and some paint. So these are the places where those torsion bars attach, and I'm going to be taking this off, cleaning out some of that old grease, checking all the holes that are threaded to make sure we can get the bolts back in, and really make sure that it's up to factory standards. This suspension's known as the double trailing arm front suspension, I think. And it uses a link pin, and it uses these torsion arms that go in the tubes I showed you on the car. And it's a clever system. It's definitely proven. You know, Volkswagen used essentially the same exact thing. And you know, there's 356s that are still driving today with 1 million miles on them. One of the disadvantages of this system is that it requires frequent lubrication. I think it's 3,000 miles, and you got to inject grease into these things because there is no rubber in any of this front suspension area. So I'm going to be pulling these links apart and checking the bushings for wear and replacing and adjusting wherever needed. I also have the ability to check that nothing is bent. This is the tool that is used to check the straightness of the torsion arms. And then this is the tool that checks the straightness of the stub axle. So I'll show you how those work as soon as I get all this stuff taken apart. It's important to note that this bolt is longer so that it actually creates a stop on the steering movement, pushes up right against here. That prevents the tires from rubbing on the body. One, two, three, four, five. 1, 2, 3, 4. And then the hard part is to come because this all needs to be pressed apart. So I'm going to let this soak with some penetrating oil and just get all the oil off of this. This one is totally worn out. Okay, I'm going to take these outside and spray them with degreaser, let them soak a while. Be right back. These are the new link pins with their bushings, and these obviously fit really nice, brand new. looks to be the right size. These are made in Germany, although these little dust cover things are different. These are different shapes, so maybe I can reuse these. I got this old shock because it looks like a piece of the old shock is stuck on this arm. So that's just part of the bushing, it's not part of the arm. That slides on there like that. So it's okay to put vice grips on this and just rip it off. Okay, I got all the parts cleaned up, but right now I'm trying to clean out the bores inside here. This is where that tool goes, and I want this to be completely rust-free and clean. So I'm using some of this metal conditioner, which is like a phosphoric acid type solution, and just a little bit of steel wool. And I need to make sure this surface is completely clean so we get an accurate measurement when we put it in the factory tool. So I want to see shiny metal in there, but I don't want to remove any metal. So this steel wool is just going back and forth, and this chemical will loosen up all the rust and treat it so it'll stay rust-free. So that's the kind of surface we're looking for, even with a dirty towel. I'll wipe this with a clean towel, but we want the inside of this bore to look like that, because that's where the measurement takes place. Okay, I finally got all the suspension arms and the knuckles and stuff cleaned up to the point where I can work on them, at least test them for straightness. So now I'm going to put a little motor oil on this tool that I have and put it in the suspension arms and see if they're bent. Hopefully not, but let's find out. There's just a little bit of grease on here so it doesn't rust. So I have the factory workshop manuals for this car, and they're the originals, so I don't even bring them out here in the garage. They're in the house. I just went and looked at the procedure, and it says that the max non-parallelism between this axis and this axis is 8 thousandths. So you use these gauge blocks to determine how straight it is. So looking down from the top, it looks pretty straight, but I need to figure out which gauge can go in there. So that's an 18 thousandths. This one's definitely 21. This one might be 23. Maybe. So the difference between that is only 2, which means it's not bent in this direction. Now we check in this direction. In this case, you just want to know that it's resting on one side. It's going to be 0 on one side, and then we'll use some small gauges to see if it's offset this way. This is 3. So 3 won't go in on this side, but it will go in on this side. So, but it's tight. Let's try 5. Nope. Nope. Yeah, that's pretty firm. So this is off by 3, which is less than 8. So this arm is good to go. It fits in this tool really well. In case you're wondering, this one is labeled P70 as well, but this is for the earlier suspension arms that are actually have a smaller shoulder here. My car is a C, so it has that bigger shoulder. At least I think that's what this is for. I don't know if you guys can see in there, but I cleaned these out all the way. They're super shiny. This one's 9 thousandths, which the limit is 8, but given how old this is, I would still give this one a pass. Let's check it in this direction. So this one is a little bit borderline. I'm going to give it a mark of meh. So hey Zach, good job on the guitar. Which car do you like better, yellow or green?
Definitely the green one.
Green one. There it is, green for the win. Yeah, the reason why I skipped over this one is because it still has the sway bar bushing in there, so it needs to be removed before it'll clear the rod that has to go through. So I gotta push that out somehow. This vise has smooth jaws, and I'm clamping on this part. This is the forged part, this is just the steel part. So that's gone. This is, I think, 3131. So this one's also thumbs up. All right, that's great news. You know, 4 happy faces and one sort of at the limit or slightly over, like 1/1000ths over. That's the upper one here, and it was an extra. So this one, I'll probably sell it. So if you're interested in this one, please let me know. And also, you know, that tool is not for sale. I know it's a rare tool. However, if you want to check your arms, I'm not going to loan the tool out, but you can mail them to me. I will gladly check them for you. As long as the parts are clean, I will do it free. The other thing they said to check in the manual, doesn't actually require a tool, is this surface on the end often has wear marks in it. So this one is really nice. Usually there's marks on only one side. This one has essentially no marks on it. This one's really good. Happens to be the one that's the medium face. This one is also good. Hardly any lines on it at all. Sometimes you get grit or sand inside the torsion tube and it sort of eats away at this. The torsion tube has a nylon bearing, and then this surface is always cleaner because it uses a roller bearing. Most of the load is on this surface. This surface is okay. This one probably has the heaviest scratches. You can feel them a little bit with your fingernail, but certainly not bad. And then one of the tricks you can do is, because this would have been on the passenger side, if you use it on the driver's side now, you flip it, that gives a whole new surface for it to wear on. So it's almost like brand new if you just take this arm and flip it to the other side. And then the last thing they said to check was really the perpendicularity of this surface where I put the inspection tool in there to this surface. So if this is worn on the outer portion, then it could be non-perpendicular. So I had an idea to check that one. Okay, this brand new link pin just happens to fit inside this hole. It's the correct diameter. So I'm going to coat this surface with the Dychem Machinist Blue and just give this a spin and see if there's any non-uniform wear on that surface. I'll do that for all 5 just to know. But what you're looking for is the way the blue wears out. So it's wearing a little bit more on the top and not the bottom, but I don't think it's bad. So if I was to put this back in here and use the thinnest gauge that I have, actually when you put pressure on it, it doesn't go in. So there's no specification in the manual for how far this can be out. It just shows a tool that spot faces this with like a cutter to reface it, like machine it down. But I don't think that's even worth doing. I think this one's fine. You can see the wear on this one is even better. It's all the way around. There's only a small portion here that's not touching. This one has a whole different wear pattern. It looks like all the wear is occurring right here at the inside edge, which is kind of different. It's a really fine file. I'm just going to try to knock the inside edge off on this one. Definitely close enough. I'm going to call, basically all these arms are good in my opinion. These guys have been cleaned up too, at least to the point where I can work on them in the press. The next job is to push out these link pin bushings. These things are extremely loose in here. So I need to get in my press and come up with a strategy on how to get these pushed out. Okay, I got my press here on the bench and I've made a few little tools to help push out those link pin bearings or link pin bushings. This is just a piece of the roll bar tubing that is cut to a length just a little taller than the actual bushing I'm trying to remove. And then this is a link pin that was taken off of the original, and I cut the length and then I ground down the diameter. Let me get another one. This is the link pin that I removed, and here's the modified version. It's just the same thing, just cut shorter, and then the diameter is ground down. So I just put this on my bench grinder and rolled it around a few times until the diameter here is less than the diameter of the bushing I want to press out. So if you can see there, so I'm not going to be able to move it very far with this height right here, but I just want to break it loose. Usually the beginning is the hardest part to move. It's usually the most force right at the beginning. I'm going to zip tie that closed. Just keep that out of the way a little bit. Yeah, that was not that hard. It already broke loose. At this point, there's not a lot of force on it. You're not supposed to use sockets for this, but I can tell it's pretty light duty. I'm like barely even pushing on it, so I'm not going to explode a socket with this much pressure. You got to go by feel on this stuff. Oh, out of stroke. So a couple more of those dudes. You can see it's elongated. It's thin here and it's kind of thick over here, so it's definitely worn. This is just hard, dried up grease. It looks like plastic. Now, it wasn't necessary to remove the grease fitting when I pushed that out. I thought there might be some interference, but apparently you don't have to take the grease fittings out. I didn't want to risk breaking them off, so I thought I would try without taking them off. So let's try the other side. This tubing is the same diameter as this shoulder here, so it's really easy to make sure it's lined up. And that should be it. Broke loose. Travel down a little bit and then put in the socket. It's good to make sure this still spins too, just to make sure you're not really tweaking anything. So nothing out here is being bent or distorted or loaded in any way, so you don't want to cause any damage when you're pushing these out. That's it, there's another one. Okay, it's fully caked with grease too. See if I can push this out and show you guys. And then now that these bushings are gone, I can see the Kingpin. The Kingpin is in this direction and it gets pushed out like that. So I'm going to have to come up with a new method to hold it this way to push that one out. Okay, it's time to remove this Kingpin, and I think this one's going to be a little more challenging. I did look at the manuals. They do suggest heating this in an oil bath of like 200 degrees Fahrenheit or something. So I will heat it. I don't know that it's going to do a lot of good, to be honest with you, because both parts are steel, so whatever you expand is going to expand roughly the same. So I'm worried about the force on this lower section. So this is a C shape. Most of the force is right here because that's where it's pressed in. And I just don't want to distort the C shape, and I definitely don't want to close up this hole here on the bottom. So the factory workshop manual shows this in a press, kind of like mine, and it shows this hole being open. So a lot of the force is supported here on the bottom. And if everything slides out well, like it would for the factory, then everything's fine, this hole's not going to collapse. But in my case, I want to be extra sure. I remember in the beginning of the video I said I don't want to damage anything. So I am going to support the diameter of this hole using the new bushings and the new pin, so that this hole, for whatever reason, even if this is rusty or it's stuck, I do not want to damage the C carrier. I did cut this pin. This is going to be what I push against on the top. And of course it's a little short, but I just want to break it loose and then I can use longer and longer pins. What I don't want is instability. If this is really tall, there's a lot of instability and I don't want that. I don't want this thing shooting out of the press. So I pushed this in partially. There's still enough room for the Kingpin to come out the bottom, but I'm going to be putting bearings or the bushings in on both sides. Okay, these are in here temporarily, and then I'm going to use the actual Kingpins. These are the new parts. They fit really tight. So I'm going to be inserting these from both sides and making sure I don't obstruct the pin. Now to get started, I can just put it all the way in like that and then go ahead and set up the press to push from the top. So I'm going to be pushing down just through there. What'll be interesting to note is as I'm putting pressure on the Kingpin, will this still turn? That's what I'm curious about. Okay, I think this setup should work. I have this flat stock here on the base just to support it against this machine flange. And everything lines straight up and down. So I should be able to just push on it. Oh, you know, I forgot to heat it. So I'm going to heat it up. Okay, it's hot, hot. Okay, it looks lined up. Glasses. Boom. Okay, so now it's released. This is still turning. It's kind of grippy. It's still pretty hot. I'll give you guys bonus points if you remember what this was used for. Now it should be ready to come out the bottom, but I had to put another tube in there. There it is. I just need another longer one. Should be the last one needed. All right, success. This is the carrier piece. These are prone to breaking, by the way. And it has a bronze sleeve bushing inside there. So those are replaceable. You push them out. then you push new ones in, and then you're supposed to ream it to the right size. After it's assembled, you ream it with a special tool. Now that's a tool that I don't have. It is available, it's like $135, or you can actually rent it from one of the VW shops. So I'm probably gonna buy it, and then if anyone else wants to use it, just reach out to me and I'll let you use it. Just pay the shipping and I'll let you guys use it. So I'm gonna order the Kingpin, the bushing set, and the reamer tool, and then after that, it should be good. Now, I don't know that it was 100% necessary to push these bearings in, the bushings in. I just had a little bit more peace of mind about it. At one point, I did feel under high pressure with the jack that the link pin was a little bit harder to move, which tells me this stuff was squeezing down. I mean, I don't think I used all 20 tons. I definitely used more than probably 2 tons on it though. It's pretty significant pressure, a little bit more on the Kingpin than there were on the link pins. So you gotta be careful when you're using your press that you don't A, hurt yourself, and B, hurt the parts. You gotta think about where the forces are acting and what it's doing to the pieces. So I felt better about the way I did it. Also, the factory manual says to heat it up in an oil bath. I just heated mine up in my barbecue. So the oil bath, there's really no difference. I mean, heat is heat. The oil bath will certainly heat it up quicker, which is why the factory probably does it. I just put it in my barbecue for like 25 minutes, and I have an infrared thermometer and I check the temperature. They got to like 220, which there is apparently a plastic or phenolic spacer inside here. It didn't seem to damage that, but you do have to be careful you don't heat it up too high. Okay, I removed the temporary bushings I put in here during the pressing. So now like I mentioned, I don't have the tool for this one, but if you kind of stack them up and look at them, you can see like, oh my God, these are totally, these look completely bent to me. And like I mentioned before, these do have a camber on them. So you have positive camber or negative camber on the wheels. So if you take one and you flip it from the other side and stack them on top of each other, they actually line up perfectly. So what I'm looking for is daylight between these two surfaces. So I just lift it up a little bit, put it back down. I'm looking for daylight between there. And if it was bent, the 7-degree offset and the angles that these are machined would be off a little bit. And I don't see any problem with that. And then I can flip them, put this one on top of here, and looking for the same daylight between there. I don't see anything. Okay, this tool is the factory tool. This is P69. It's pretty easy to use. You just slide the parts in. It has machine bosses on here. I probably should clean this. Those machine bosses tighten up against or press against these 4 right here. And then you just rotate it to this point and look down in there to see if the holes line up. Which they look like they do. This side's still a little warm. Okay, this side looks a little further off. I'm going to get the steel wool and clean this up. Someone probably had this job at the factory to keep these tools shiny. Yeah, so this one, it looks like it might be off. Yeah, I'm looking into this tool a little more carefully, and the way it's supposed to work, as I mentioned, are these machine bosses on the stub axle are supposed to slide on the machine surfaces on the tool. And they do that just fine right here. Everything's resting against there and everything is nice and flat. But the moment this portion where the brake caliper attaches, it actually interferes with the tool a little bit. So right when this piece moves over here to line up to the hole, this part contacts the tool and it lifts it up. So this boss is no longer supported on the machined surface. So right when you check it, the whole thing gets twisted up in the tool, which I don't think that is supposed to happen. You know, this is a painted surface. Clearly it's not designed to make contact with this part. It's supposed to make contact with these four bosses. Nice and flat, and then it jumps up. That seemed to do the trick. You know, typically you don't modify the tool to fit your parts. But in my case, I knew that this surface here, you can see it has a tiny little bit of rust speck on there. That's where it was contacting. And this is a forged surface. It's not a machined surface. So that's not the precision surface you're supposed to measure from. And it just so happens that, you know, this is a 1964. It's towards the end of the production of the 356. For all I know, this tool may have been designed for an earlier model that didn't have disc brakes. So that's probably the factor here. So what I had to do is I had to just blend in this surface right here. So I went down beyond just the paint. I went down to this previously machined surface. So right here at the leading edge of this little triangle, it's even with the machined surface, and then it kind of slopes up a little bit. So now when I put the part in and rotate it around, it fits up here like it's supposed to, which means the axle's not bent, which is great news. And it also shows me, if I look really carefully, that it's resting on all four of the machined surfaces. And this portion here, which is the non-machined surface, has just a tiny bit of daylight underneath it, probably just a few thousandths of an inch, because I didn't want to modify this tool more than I needed to. And then the same thing is true on this side. Although for some reason this side's not as bad. So you can see it is hanging up right here. This is where the caliper attaches. It is making contact, but it doesn't actually make a step up. So I'm going to clearance this one just a little bit less and just double check this side now that I know that this may not be the right tool for disc brakes. Okay, on this side, it didn't really affect the measurement as much, so it's still good. I did make sure though that it's not resting on the forged surface. It definitely clears it just by a tiny little bit. So I'm good to go on the stub axles. I'm confident they're not bent. I'm glad this tool worked, but I'm also glad that, you know, I caught a little mistake in that. There's a guy in San Diego, John Boonin, or Boonin, I don't know how you say his name. He collects all the Porsche tools. So I might give him an email and just see what he has to say about that tool. I'm sure he's well aware. I made another tool out of the old link pin. So this was the section I cut off when I made this tool. This is the one I used to push out the link pin bushings. Well, this is the remainder of that, and I just welded a washer onto the end. So you can see there's a little tiny step on there. Hopefully you can see that. Just a little tiny step on that, and it's sort of plug welded or rosette welded on the end with a TIG welder, by the way. A lot of people don't do rosette welds with a TIG welder. But I hope that's going to be strong enough to push out these bearings or bushings inside the carrier. So they're brass. I don't think they're held in there with a lot of force. So this tool is going to go through them. That little step of the washer fits pretty tight. So that little step on the washer, when I push down on this, is going to touch the sleeve bearing and then push it out the bottom. So I don't want to put pressure on the C because I don't want to deform the C. I just want to, you know, put pressure down here on the bottom and then push it out through the bottom. That's what I'm going to try. I'm not going to, because it's not that much force, I'm not going to put the supports in the circle. I don't think it's going to be that strong, but if I do feel a lot of pressure, then I will put those back in. But this should come out pretty easy. Now this is pretty long and slender, so if anything's going to slip out, it's going to be this one. So be very careful with this. All right, that did not seem to work. And my washer completely disintegrated on that. So that's too bad. I'm gonna push that through and come up with something better. Okay, so that was a total failure. This washer was not up to the task. Now, I have access to a lathe under normal circumstances. This would be an easy thing to do, is to machine a little step in a push bar, but that is closed. I don't have access to that right now due to all the lockdown restrictions. So I'm gonna have to come back to this one with the proper tool. I thought I can get by with this, but clearly it's not up to the task. Even though that tool disintegrated, it did not damage the part, and that's definitely what I was after today. I think I got a lot of it stripped down. I now know what is worn, what needs to be fixed, and what parts to buy. So I'm gonna take a break after that little moment. Take a break and come back next week with hopefully the correct parts, or maybe even work back on the 911. Take care, guys. Thanks again for watching.